Hello and welcome to this short tutorial on the WCI terminology service in 5 minutes GitHub project. This is a open project on GitHub to provide information about interacting with the WCI terminology service APIs. The video you're watching here is available from this link. This provides examples in a number of languages for accessing the API and information on how to get tokens. There's two key reference deployments listed here. There's the one at wci.terminology.tools. This is an authenticated platform and can be accessed via the API by a 30-day token that we can grant. Otherwise, it is actually accessible in the browser mode with login from the UMLS UTS service. There's also a deployment at snowman.terminology.tools that is unauthenticated and does not require any login in order to use. This project is fairly straightforward. It has tutorials in a number of languages or modes of operation. We will be adding to this over time, but for now it's Bash, curl, and postman examples. And each of these has their own training video that you can find by clicking on these three links here. Currently, this project covers a few simple use cases: logging into the server, getting a list of terminologies, getting a concept in a terminology by a code, getting the concept relationships within a terminology for a code, and then the relationships are all the codes on the other side of that, finding concepts by a search, and then obtaining a concept subtree. This project has some additional resources as well. There are the Swagger pages for the two reference deployments listed, WCI-terminology.tools and snowman.terminology.tools. There is a link to the full terminology server documentation, which includes also some information about how to use the browser. Additional documentation is just a link to other resources where we can answer questions and share additional details about interacting with the API. And data loading documentation is about how to actually load the environment if you wind up using this platform and need a script for loading a Postgres dump file. This indicates that you should request a 30-day token from info@westcoastinformatics.com. Should you do that, you'll wind up receiving an email like this one that indicates the token that can be used to access the server. And this is how to use this is explained in the Bash, curl, and postman tutorials shown. But I'll do a quick little demo here with the Swagger API, which you can also use. So if we open this, then you can come here and click on the authorize button, paste this token in, authorize. Now you're ready to go. Close this out. You can pick a endpoint that you want to call. So terminology, for example, and I'll click execute here. And you can see the response comes back and shows the terminologies that are loaded: ATC, CVX, ICD-10, LOINC, MEDRT, NCI, and some other ones here. That's a really quick introduction to WCI Terminology Server in 5 minutes. And come here to GitHub and click on any of these to find more information about specifically how to use the examples provided in these situations. Thank you very much. Hello and welcome to the WCI Terminology Service in 5 minutes Bash tutorial. This project is available on GitHub and publicly accessible. To get to the Bash tutorial, scroll down on the main project and click for Bash examples. Here, the training video that you're watching is available in the top link of this page, which you can see is right here, Bash tutorial training video. To run this tutorial yourself, there's a few small prerequisites. Bash must be installed, as well as curl and JQ, which are used by the Bash scripts that are involved here. There's two environments that can be used to interact with these scripts out of the box. Both are reference deployments of the WCI terminology server. The first, WCI terminology.tools, requires a token, a 30-day access token can be requested from info@westcoastinformatics.com. And snowmed.terminology.tools doesn't require an authentication token, but only allows you to interact with Snowmed content. If you do request a 30-day token, you'll get an email like this. And here you can take the token and set a token variable in your shell that will be used to authenticate the various calls. So here we are in a checked out copy of the GitHub project. We'll go to bash examples. And then here, there's a url.env file that is used to configure what endpoint the various scripts talk to when they're called. So we have this set to wci.terminology.tools, but it could be set to something else instead, and the scripts would still work. We're going to go through a few examples here. Logins not necessary. It's for environments that are authenticated by username and password, and the reference deployments are not such deployments. So we'll go through an example of looking up terminologies, of finding a concept by code, of looking up concepts relationships, of finding concepts by a search string, and then getting a concept subtree. So if we come down here, you can see first get terminologies is a script that essentially returns all terminologies that are loaded in the reference deployment in this case. So we can just take this command and run it as it is since we've already set our authentication token. So we'll run this and you'll see that basically it calls the server and looks up all the terminologies that are installed. So there's 10 and here's the kind of detail. So you can see these abbreviations are the terminologies, ATC, CVX, and so on. This includes ICD, LOINC, SNOMED, and ARCSNORM. So all the kind of classics in the US. That's getting basic terminology metadata. Next example is getting a concept. So we can make this call here. What this does is look up a particular SNOMED US extension code by its code value. Okay, let me go copy that again. Okay, so this makes a call to the server to find this SNOMED code and it returns a JSON payload that represents the content contained. So here we have our code heart structure from SNOMED and a variety of the names associated with it in this atoms array. So these are all the different ways in which this concept is labeled. And the reference deployment loads SNOMED US extension from the UMLS. And so the representation has some of the features of that representation. The next example is to look up the relationships for this code. So here we can take this, and what this command does is find the relationships for this code, limiting to 5 and sorting by additional type. So just demonstrating some of the additional parameters here. Oops, having a copy and paste issue here, so do that. So there you go. We've called essentially looking for the relationships of the heart structure concept we were looking at before. So this has a limit of 5, but returns 4 entries, and each one of these entries essentially has the information about the related concept on the other side and the nature of the relationship. So here we have a hierarchical is a relationship, and so the 2 terminology coded name are a parent concept of this concept in the SNOMED hierarchy. And then here we've got another parent and then a couple of other relationships, has part anatomy structure and has entire anatomy structure. This is a very simple example of looking up related concepts on the other side from a concept code. The next example goes through performing a textual search. So this example is going to perform a malignant melanoma search. Again, that didn't work for me, so let's try that again. We're going to search the string malignant melanoma with a limit of 5 results. And here you can see that there are a total of 448 matches, 5 of which come back. And there's a simplified view of the results here that give you the name and the code and the terminology and a few other little details about the search results. So the top 2 results are the exact matching disorder and morphologic abnormality codes in SNOMED, which is exactly what you would expect. There are other search parameters which we'll take a look at in a second, but that's the simplest example. And then finally, we have an example down here of performing a search to get a subtree. This is actually set to look up an ICD-10 code instead of a SNOMED code, just to show use of a different terminology. So again, this code, this example as written would not work against SNOMED.terminology.tools because ICD is not loaded in that environment. So here we're going to find the subtree starting with the code M01 and looking a max of 3 levels down in the tree. So if we run this command here, you'll see that the result is basically a subtree. So we have our code eventually at the top here, M01, and then it has children, which include M01.x, which has children M01.x0. And then here is the third level down, M01.x11. And then this kind of pops its way back up. We've got M01.x2 and so on. So this is the entire subtree below a certain code in the terminology. And the same sort of approach would work against codes from other terminologies as well. One other thing to point out is that in each of these cases, we can call the corresponding script to retrieve information about how to interact with it. So let's go back to the top here and look at get terminologies. So if we run this without any parameters, it tells us how to call it. So with an example. And then if you go to the next one, similar sort of thing, get concept with no parameters will show you how to call it with a few examples. So in this case, it just takes a terminology and a code. Same with concept relationships here. So we could call this one without any parameters. And it has a few examples of how to call it. So with limiting and sorting by a particular field are other options. There's also an offset parameter here, so you can start not at the first page, but at later pages and page through the results. Then with find concept, similar thing, run it with no parameters. And we can get a look at how to call this. So a little bit more complicated, but so you can just provide a string or you can provide a limit. There's this notion of a resolver that provides different levels of detail in what gets returned. You can call this with expressions as well as text searches, and there are just some other kind of examples in here. And this goes a lot deeper, and we're happy to have a conversation about the full capabilities if that is of interest. And then finally, the subtree call will do the same thing, just run it without any parameters. Oops. And you can see how to call it. So here, essentially takes a code and then a max level parameter. So if you're only interested in a partial subtree, you can perform that test. This has been a quick introduction to the Bash tutorial for the WCI Terminology Service in 5 Minutes project. Thank you very much. Hello, and welcome to the WCI Terminology Server in 5 Minutes curl tutorial. This project is available on GitHub and publicly accessible. To get to the curl tutorial, scroll down on the main project and click for curl examples. Here, the video you're watching is also available from the link at the top of this page. To operate these examples, there are a couple of prerequisites. They all use the curl and JQ commands, and so you need to make sure these are installed in your shell. There's two reference environments against which this tutorial can be run, wci.terminology.tools, which requires a 30-day authentication token, and snowmid.terminology.tools, which is open, does not require real authentication, but only has snowmid as a terminology loaded into it. A 30-day access token for the reference server can be requested from info@westcoastinformatics.com and then set in a variable. We're going to use that here for this tutorial. If you request a token like that, you'll get an email such as this one here that contains the token. Then in your shell, you will set the token equal to this value, and then you'll see how that gets used later in the sample curl calls. This documentation goes through a number of different examples of calling the API to produce results. In the documentation are the actual calls you can make and then sample documents that show what the payloads that return look like. All of these require an API URL variable to be set as well. And so we're going to set that to wci.terminology.tools. So here we go. Okay. So our first example is a call to basically get all terminologies that are loaded into the server. So we'll do this here. Just a simple curl call with the authorization bearer token and the terminology endpoint. And then we're piping the result through JQ here. So you can see the result is an array where each element is one of the terminologies that's loaded into the server. There's currently 10 terminologies loaded. And each of these payloads contains the source abbreviation, the name of the terminology, the version, and some other pieces of information of interest. The second example we'll look at here is obtaining a concept by a terminology and code. So this example looks up a SNOMED code for heart structure. And this returns information about this concept. So we'll just run this here. And you'll see this is a JSON payload with details about the concept, including the name, code, and terminology of the concept, and then all of the different names that this concept has here in this atoms array. So heart NOS, heart structure, heart, and so on. These are all the different names in SNOMED for this code. And then we've got some attribute information here. The data in this reference environment is loaded from the UMLS rather than the SNOMED RF2 files. And so the representation you see here is based off of how it's represented in that environment. The third example is showing how to obtain relationship information, also for a concept and a terminology. So we're going to look up now the relationships for the concepts that we just looked up. So put this in here. Again, all of these are really doing the same thing, just passing the authorization parameters and then calling the endpoint with relevant path parameters. So this concept has 4 relationships. Each of these indicate the thing that this relationship is pointing to on the other side. The from side of this relationship is represented in the parameters. So when you make this call, you already know which code you're going from and which code you're going to. And each relationship contains information about the type and the code that it's pointing at. So here you can see that structure of thoracic viscus is a parent concept of the one that we're looking at, heart structure. Okay. Next example is finding concepts by a search term. So this is an example of performing a text search into the database and returning matching results. And so, oops, here, let me redo that. We'll perform a search for melanoma. And we're limiting to 5 results here, and we're using the min resolver, which is intended to produce the smallest amount of data in response. So we have search results that are small and simple. So here you can see there's a total of 448 actual matching results, but we've limited to 5 results. So these are the results in sort order. So the top 2 results are the disorder and morphologic abnormality concepts in SNOMED for malignant melanoma, which is what you would expect. There are other parameters to perform paging with limit and offset. The results also can have a resolver that produces more information, and that's sort of elsewhere in the documentation. But this will get you started on performing text searches. Here's an example of performing a search that uses both an ECL expression and a textual component. So here, oops, let's go back and copy that again. So here we're performing a SNOMED search again for melanoma, but this time using a descendant of expression to constrain the search results to a particular subtree. Here you can see instead of the 488 entries in the previous case, there are 180 results. And of course, we're limiting in this case to just disorders. So you can see all the results are only disorder kinds of concepts, or yeah, diseases in SNOMED. That's the expression constraint we're using. And then finally, we have an example of obtaining a subtree. So here, this calls using a different terminology. We're going to look into ICD-10 CM, and we're going to look for the subtree starting at the code M01 and looking up to 3 levels down into the tree. That's what this call does. And you'll see this returns a relatively large payload that represents essentially the entire subtree of content from this code down. So at the top, we have M01. Then it has children that include M01.x, which then has children that includes M0x0, and then M0x1, which then also has a child of M01x11. So This will eventually, if we scroll down, kind of pop back out, and you'll get the other children of the top level nodes and so on. So this is a way of obtaining essentially a portion of the subtree from a particular node, looking a certain number of levels down. That's a very basic view into a few calls into the WCI terminology service using curl commands and a 30-day authentication token. Thank you very much. Hello and welcome to the WCI terminology server in 5 minutes postman tutorial. This project is available on GitHub and publicly accessible. To get to the postman tutorial, scroll down on the main project and click for postman examples. Here, the video you're watching is available from this link at the top of the page. In order to use Postman, we're going to have to download this Postman collection. So let's do that. This will take you to GitHub. You can click on raw, and then we can save as and save this file. Then we can take this file and load it here into Postman. I've got a fresh collection open. Drag this into here and import it. Okay, that gets our Postman set up. Okay, so the next thing to talk about is authentication. So there's a couple of reference terminology server deployments available that can be used. There's wci.terminology.tools and snowman.terminology.tools. For the WCI one, you can request a 30-day token from info@westcoastinformatics.com that can be used, and that is what we will demo today. You can also test many of these examples against snowman.terminology.tools where no authentication is required. However, only SNOMED is loaded into that environment. This next set of instructions is really for a local installation that uses username and password authentication, which we're not going to cover today. And everything else about this tutorial is really in the Postman collection itself. So we're going to go take a look at that. If you request a 30-day token from info@westcoastinformatics.com, you'll get an email like this one that contains your token. And then we're going to go show how to set this up in the collection. So we'll come back to Postman over here, open this collection, and then here we'll go to edit on the collection itself and go to the authorization page. What we want to use here is a bearer token, and we'll just paste our token in. And that is essentially ready to proceed with making calls. So we have 6 examples of things that we can show here. Before we go on, many of these examples make use of variables. So in particular, they specify an API URL that is currently set to wci.terminology.tools. If you wanted to test this collection against another deployment, you would want to change this to point to the URL of what it was you wanted to test against. And you'll see that here in the terminologies call, we have, here, let's close some of these other ones. We have just a simple API URL terminology call, and we click send. This is an authenticated call, so it sends the tokens in the background, and then here in the results, you can see that we get back essentially a list of the installed terminologies with some information. Each JSON payload, each element of this JSON array that comes back represents a terminology with its name and abbreviation and version, and then some other information about metadata about that terminology. The second example is looking up a concept by code. So if we come here, you'll see that we're performing a search for SNOMED CT and a particular code. And this is essentially going to do a basic lookup of this code in the terminology server. So here we get our response back. It's heart structure concept in SNOMED. And then this atoms array contains all the different names. So we've got heart NOS, heart structure, heart, and so on. These are all the names of this concept in SNOMED itself. And then at the bottom, we've got a few top level concept attributes and the semantic type information. So this is a basic model, simple lookup of concept level information that includes the top level concept stuff plus a few other details. The next example here is to look up the relationships for a concept by code. And this example uses the same code. So what we're going to do is essentially look up the related concepts of heart structure. So send this call in, and we get back 4 relationships in an array. Each one of these is all the information, including what it's pointing at, what kind of relationship it is, and so on. So here from this first one, you can see this is indicating that structure of thoracic viscus, that our concept is a child of, it is a structure of thoracic viscus. So the two concept in this case is a parent concept. So that's, and then there's a few other kinds of relationships here as well. That's a basic call to get the relationships for a code. Next example performs a text search. In this case, we're querying the search string melanoma, and we're requesting a limit of 5 results back and choosing a min resolver, which is a resolve that returns the kind of minimum amount of information. So this is a mechanism that lets you produce varying levels of detail in the response to a call like this. So we'll perform the search, and it comes back with 5 results out of a total of 448. And these are in rank, search result rank order. So you can see the top 2 are the disorder and morphologic abnormality concepts for malignant melanoma in SNOMED, which is what we would expect. The next query shows, the next example shows that you can actually query by search term and an expression. So here we're going to query melanoma, but only for descendants of this code, which is the code in SNOMED for the diseases or disorder concepts. If we send this through, you'll see that the search results are much fewer, only 180, and our top 5 here only include disorder concepts in SNOMED. So that's just a way of showing that we can support ECL constraints alongside with search queries and other parameters when looking up content. And then the final example is to obtain a subtree. So what this call does is take a particular code and a terminology. In this case, we're going to look at ICD-10 instead of SNOMED. And it's going to look up the subtree starting at this concept and up to a max level of 3 down into the tree. So here you'll see that the response is a payload representing the top level information at our code M01, and then showing that it has child concepts that include M01.x, which then has child concepts that include M01.x0. Here, X1 has another child because we're going 3 levels deep. That's M01.x11. And then we kind of stop here because this is the 3rd level that we want to go down. And then looking through, you can see this kind of pop back out as we go back up the tree. And so this is essentially a rendering of the entire subtree under this code M01. So this has been just a quick presentation of 6 kind of calls that you can make from the perspective of a postman collection. Thank you for listening.